It is time for Astronomy Daily Live. Hey, 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 everybody. Hope everybody's doing well. We're just going through a little bit of a sunset here. There's there have been some fires in the area, not anything nearby or anything, but quite a bit of smoke. Quite a bit of smoke. So the sunsets, at least for the next few days here, are going to be pretty intense. So I'm sort of standing by to see how red this actually gets. Um, the sun is about, I would say, maybe 15 minutes until sunset or so, maybe a little bit less than that. So we'll watch this. We'll watch this reddening sunset progress. In the meantime, let me pull up my smartphone so I can watch the live video. I tweeted. Can't believe it. I actually did. I tweeted. So yay. So yeah, I hope everybody's doing well out there in the universe. Oh, that's what I need to do. Pull up my chat. Pull up my chat. Heidi ho. Heidi ho. Hey Patrick. I know Gilles is still live streaming, and yeah, he has a lots of fun, lots and lots of fun with that. So yeah, yeah. Uh, I don't feel any kind of competition at all. I think he'll just take everybody. So and that is cool with me because I'm just here talking astronomy, and in a very, very loose, fun, casual way, and whatever. Righty. Slight lag before player actually loads. Okay, yeah, yeah. I'm one of those. I'm one of those purists, right? That it's like given the opportunity, as soon as I see 2 hours, bang! It's like wham, like that. But what you're suggesting um, is that I wait just a little while. Yeah, I'll try that, um, Uncle Bill. I notice that other live streamers do that and pause way too long and have their microphones on, and sometimes you can hear them breathing, sometimes you can hear them typing, sometimes you can hear them messing around with things on their desks, and there aren't. I'm really tolerant, right? I really am. It's like, do whatever you want, right? But some things sort of bother me a little bit, and one of the things is those pauses um, before the live stream. And I mean, uh, the pause is the lag time, right, between what I'm doing live here and what you're seeing, and it's about 20 seconds or so, right? 20ish or so. Uh, Miss Lady Catherine, hey, 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 nice to see you in the room. Hearts all around. Glad you could stop by. Yeah, I will I will pause. I will count to maybe I maybe five, right? Maybe count to five, um, because yeah, I that's just one of the things that I find annoying is this very, very intentional pause. How's our sunlight doing back here? It's looking. I'm just looking out the here. Do you want to see? This camera is not going to show you much of anything at all. All right, it's just going to show my dirty window, my dirty window, my peace curtains. Yes, those are peace signs on my curtains. Isn't that cool? And a cool material, uh, or cool pattern. Anyway, there's the sunset, and it's not very interesting through this camera because this camera, sucks. So, but there it is for what it's worth. Now I need to set this up again and make sure that there's no incriminating images being sent throughout the world. So, um, all right, well, cool. I I just have one maybe short comment about the news today that came from the Mars Curiosity rover, uh, uh, the Mars Science Laboratory (MSL), um, uh, and I guess I mean, I I know that I have sort of certain biases about things, and one of the biases is that I have is that if I see the crowd sort of going off that way, well, I'll go in either the opposite direction or the right angles to that. So maybe this is where that is coming from, but I'm not exactly sure why astronomers are interested in life. I'm not exactly sure why that's so motivating. Um, I mean, I think that you know finding life or signs of life elsewhere, yeah, is going to be very cool. But I also think that it's very likely to be um, inevitable, right? I mean, the only thing I can think as an alternative to that is that something has to be first, right? That's I mean, if you agree with this thing that the universe has sort of been evolving, and we're a product of that evolution, well, something has to be first. Um, and maybe the planet Earth is first. I don't know, right? Now that seems unlikely, right? Just given um, um, the numbers involved, right? I mean, there's just a lot of stuff out there. So even if the probability is low, there's still going to be a lot, right? So that's sort of where I'm leaning. I'm not going to be surprised in the least when life or signs of past life has been found elsewhere. I actually think it's probably a lot, and this is just an intuition. This isn't based on any hard evidence or anything else, but I think life, and in fact probably intelligent life, conscious life, I think that's probably maybe a little bit easier than what we think. So uh, and we can get into it's like, okay, well, if it's so common, where are they, right? Fermi's paradox. But um, yeah, I don't know, and I have that's fine with me. But I think life in general is probably pretty easy, and um, and so I guess I don't get too excited about these discoveries of carbon-based molecules on Mars, and methane in the air and all that. It's just, I mean, yeah, it's an interesting discovery, and it's cool and all, but I don't know. I just don't get all that excited about it. So because it's sort of like, well, yeah. I mean, it makes sense. Cheers. This is hydrogen hydroxide tonight. This is to calm me down a little bit. So cheers. Ah, so so he started and stopped his test stream 7 times until he got it right. Well, cool. But yeah, um, I'm probably not going to be that OCD about it. I can be very OCD if I want to be, but I sort of have my hand on that dial. So I will definitely take your advice though, Uncle Bill, and give it a little bit of give it a little bit of a pause at the beginning, and go from there. Oh, it's getting pretty red. It's getting pretty red over there now. So yeah, nice red Arizona Arizona burning sunset. Yeah, actually, I think the fires aren't around here at all. They're down in Mexico, and they're over in New Mexico. So we're just getting a lot of a lot of stuff. So yeah, yeah. Gilles is on right now, so um, feel free to jump over there, check mine later, or do vice versa, right? I mean, either one you can watch later. So or you can do it ninja style, like Uncle Bill, right? And have 50 screens up at the same time, and he's not only watching all of them, he's listening to them and participating in all the chats, right? At the same time. Yeah. So very, very cool. Anyway, so I'm as I said, I'm not quite sure why astronomers are so excited about using their time and energy and resources to look for life. I don't I guess I just don't see that as sort of what astronomy should be doing. Astronomy should be studying the universe, right? Not necessarily looking for life. So that sounds like biology, and there are people who call themselves astrobiologists, right? I mean, they're currently out of well, they aren't um, out of jobs. They've convinced people with funding to hire them to be astrobiologists. And currently, right, there is no such thing. There's no such thing as astrobiology. Now that is going to change, right? So I guess they're just sort of preparing themselves. They're getting what 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 they think might be some expertise in that field, although that field does not exist, right? It doesn't exist yet. Um, anyway, that's sort of the skeptic in me coming out and being like, why are astronomers interested in biology? I don't know. I don't quite get it. And that just sort of piggybacks on with at least my opinion that life is probably very abundant, very very abundant, and so I mean, if anything, right? If anything, the discovery of life, what that's going to do for me is it's going to give me a little bit of relief. It's like, phew, it's about time, right? It's about time because we've been excited about trying to find life elsewhere for quite a long time, right? And we're all excited about it and blah, 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 blah. But I guess I mean, there was a time in my life, I guess, where I was that way too. It's like, wow, that's going to change the world, right? That's going to change the world when we discover life elsewhere. And maybe, I don't think it's cynicism. I don't think it is. I'm just, maybe it's just because I do have some years behind me, and I can look back and it's like, I think the idea that there's life elsewhere, I don't think people are really going to care much about that. There's going to be some that will, but it really isn't going to affect everyday life, or life, here on Earth much at all. Now, it is going to do all those things probably that are promised, right? It's going to offer us a different perspective, which will help us, those who care, understand, a little bit more about us. And I suppose that's okay. Um, yeah, I think that's okay too. So, there are people who are interested in those kinds of things, and I think that is totally cool. And that's part of the open-mindedness I have, right? It's like I'm not interested in, you know, closing any of them out or anything. Um, I'm just I'm not I, I guess I'm just not as excited as most about the prospects of life, elsewhere. I just think, it already is out there, and it's just a little, it's probably going to be, um, something that we don't expect, right? And so right now we're just not looking in the right way because we're looking in the ways that we think it should be. And if it isn't like that at all, then, you know, who knows, right? And look, we, I mean, take birds, right? Birds have a very, very, very complex language that we don't understand at all, right? So, if we don't understand the language of living things on this earth, um, uh, that we have, been around for, thousands and thousands and thousands of years, how can we possibly expect to be able uh, to know how other forms of life communicate? I don't know. I don't know. So, maybe we're just not, looking in the right way. Maybe we're not capable of seeing it or hearing it. Who knows? Who knows? But I think that we will find life like us. It seems to be a pretty good design, right? Pretty robust. So yeah, yeah. Anyway, as I said, as an astronomer, I'm not too interested in life. Um, at least in using my, resources and experience and knowledge and everything to find life. Um, yeah, yeah, I'm not. Um, I think astronomers are sort of needed to collect the data, right? But I don't, and I guess that's another thing. I'm not quite sure that astronomers are qualified to be looking for life, right? As I said, astronomers have the instrumentation to collect the data, right? But should the detection of life be left in the hands of astronomers? I don't know. I don't know. But yeah, see, and that is, um, uh, sort of where I'm going, Uncle Bill. Is that cross training, cross, discipline, um, astrobiology, right, is going to be a thing, a real thing one of these days, not just a theoretical thing, that somebody, is sort of paying for. It's going to be a real thing. Now, let's look at this. Yeah, the sunset's pretty nice over there. I can at least provide you with some color. right? I can't really see any detail through my tree there, but yeah, we're seeing some pretty decent color. Pretty decent color. Kind of hard to see, I know. The sun has set, so that's just bright sky you're looking at over there. I don't know if I can no. Anyway, so yeah, nice sunset. Nice sunset. All right. Well, let us move on. Let us move on. Why don't we there's so many directions that we can go here. Cheers. Oh yeah, I think Patrick, I mean, we there there's enough room for all of us. So you know, don't feel bad that you want to go see somebody else or anything because I mean these are recorded so you can watch it later, right? So don't sweat it. And if you don't want to watch it later, watch it tomorrow or next week or next month, right? No worries, no worries. Look, this live stream is very casual. It's very fun, right? We're just shooting the breeze, talking astronomy, and that's it, right? And if you need to be somewhere else, go for it. Go for it. No worries. No worries. All right. Well, cool. I was going. I saw that the latest archive.org papers came out and found kind of an interesting one again. So let's dive into that a little bit. So I'm going to share my screen and I'm going to hide that away and we're going to go over to Discord. So I saw this one. The what does it say? The internal rotation of globular clusters revealed by Gaia Data Release 2. And I thought that was pretty cool that they're, I mean, Gaia Data Release 2 is providing, positional information and also motion of quite a few stars within globular clusters. And so I thought that was pretty cool. And so I figured maybe we'd take a look at that a little bit. Just, you know, again, I'm sort of mostly interested in just looking at the pictures. That's my favorite thing. But reading through the captions and going through the papers a little bit, see what we can glean off of this thing. Now, I've looked at this already a little bit, so I'm a little bit ahead of you um, in terms of that. But they're talking about three-dimensional kinematics. That's just the sort of the um, uh, the measurements of of the motions, right? Um, but yeah, that's pretty cool. First, um, a quantitative study of the internal rotation of the plane in the sky for a large sample of globular clusters um, using the proper motions from Gaia Data Release 2. Um, so thought that was kind of interesting. Gaia data release 2 is available to anyone, right? So, and I mean, what these guys are doing, I mean, what a lot of these papers are coming out doing is sort of a statistical thing, right? I mean, they've uh, they've created a query for the database and have extracted information out and then look, they've looked at that information in many different ways, and I just like to see how they're doing it. Right, it's pretty cool, and I don't. I mean, they say here that this is the first quantitative study of the internal rotation. So that's that's pretty cool, to actually uh, get a sense of how the stars inside of globs are moving. Um, that's uh, that's pretty cool. That's pretty cool. So on the theoretical side, the presence of a significant amount um, of internal rotation raises a series of fundamental issues connected to the formation and evolution of globular clusters. Rotation is expected to change the long-term dynamical evolution, with a number of studies indicating that rotation accelerates evolution and strongly shapes their present day morphology, which is just shape. um, Even a low amount of angular momentum um, in today's globular clusters could represent the fossil record of a strong primordial rotation. That's cool. Finally, signatures of internal rotation could be crucial in revealing the formation mechanisms of the still unresolved puzzle of multiple stellar populations in globular clusters. They're talking about, like the blue stragglers and the yellow dudes and all that. The idea, right, is that the globular clusters formed at the same time that the galaxy did. So, you know, given that we think we have a handle on their ages, then it's sort of like, well, all those stars inside of globulars should be like old and red, right? Old and cooled down. And when you look at globular clusters, you're seeing, lots of red ones, but you're seeing blue ones and yellow ones and orange ones and just all over the place, right? So it's like, what's going on? Um, so here's some. So they chose they chose like 51 clusters to look at. Um, which is cool. Uh, let's see. So then they get into these rotation measurements, which I think are pretty interesting. So well, here's just, you know they picked out all the red stars, saying that that is the population that we're going to look at. So that's pretty cool and this is just an example, right? They're showing it for NGC 6656 and NGC 6352. I wonder if there's an HST image of NGC 6656. Yeah, I'm gonna go off on a tangent. What is it called? 6656. Let's see. NGC 6656. We'll do all the images. Let's see if HST ever looked at it. Ka-chunk, 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 ka-chunk. Oh, yeah, quite a few. 378. Oh, is that also M22? It looks like it is. Yeah, it looks like that's M22. Okay. So, well, let's just look here. This is in the visible, right? 547 nanometers is right in the middle of our sensitivity. So yeah, let's take a look here. Now, of course, these aren't going to be in color because we're looking at just one, you know, this thing through one filter, one color filter. So I guess I'm seeing a concentration of stars there. I'm not going to argue that one much. Let's see if there's any other ones. This is a different wavelength or a different filter. It's 467 nanometers. Here's a 275. That's in the ultraviolet. Okay, yeah. Let's sort this by start time here. Sometimes we get some newer stuff. I thought M22 was a little more a lot more bright stars in there. But yeah, there's definitely a concentration, so I'm not going to dispute that. These people know what they're doing. I, on the other hand, barely know what I'm doing. But yeah, if I were to take these right at three different wavelengths and assign a red, a blue, and a green, then you would see that there are quite a variety of colors. Some pretty good star images though here. Pretty cool. Wow. So this is a long exposure one. Look at that. 2,600 seconds. Let's see what that looks like. Oh, that's not really, I don't know. I'm a little surprised and confused, but yeah, seeing quite a few stars in there, I guess. I guess I'm just expecting to see more than that. I don't know. Here's 2436. Yeah, I don't know. Pretty cool though. All right. So let's not uh, let's not get stuck on that too much here. I'm gonna show these pictures off because these are kind of these are interesting ways to represent um, this this data, right? So over on the left side, okay, for a particular object, right, NGC 104 in this case. Um, so this is what's called a radial plot. A radial plot. So this axis is the distance from the center in arc minutes, and they've probably done some kind of average thing here. Yeah, it's kind of hard to explain without drawing it. Um, um, let's see. Can I? Is there a? Oh, we can use this actually. Okay. So what they've done, right, um, is they've determined what the center of the cluster is, and let's just say it's here, right, where my cursor is, right. Then what they've done is they've um, uh, taken a profile of this line, right? That's going to go from the center out to some um, radius, right? Just, so they do a profile plot of just that line. And then they'll change the angle a little bit, and they'll do this line, and then they'll do this line, and they'll do that all the way around, and just take the average, right? So that's what's called a radial plot. I hope that makes a little bit of sense. Um, but that's what this is, and then this axis is just the radial velocity. Uh, Radial velocity? No, the proper motion. So the actual motion of these stars, and what you see, they've sort of combined when they could Gaia data, which are the black dots, with some other observations. And what they're seeing is that as you move from the center of the object outward, you get these places where the proper motion is different, right? The proper motion here is almost zero, right, in the center, and is sort of at a low point, maybe about 5 arc minutes out, and then it starts to come up again. So yeah, kind of interesting. And so this plot here is showing the actual location in space, right? So this again would be the center of the cluster, and then this is what 5-10 arc minutes around or so. So yeah, I mean a small patch, but then the color, right, is representing again this proper motion. And so you're getting a proper motion as a function of position in the sky. And so, yeah, you sort of see that, over here, you've got proper motions around these values, right? And over on this side of the cluster, you're seeing proper motions that are more, right? So kind of interesting, and kind of an interesting way to represent the data. I'm not exactly sure, why it's sort of cubey like this or blocky, but uh, yeah, I think if I studied the paper a little bit more, I would understand that more. But I mean, it has to do with the data points, that they're using. So, but yeah, I'm not exactly sure how that works. I can make some guesses. So anyway, they show these for a bunch of clusters. Um, I guess these white arrows, they sort of explain that here. The arrows indicate the position angle of the rotation axis derived from line of sight studies. So I guess these arrows are what they think are the rotation axes of the clusters. So yeah, that's kind of cool. But kind of you know quite a few of these are sort of different, right? I mean, it sort of looks like this has I mean, both of these, especially this top one, you can sort of see that over here it's more yellow and green, and here it's more blue, right? So I mean, there is definitely sort of a difference here. And even I guess sort of with this one, maybe you're seeing that, but this one's kind of interesting, right? Because it looks like um, uh, stars more towards the middle of the cluster are moving faster than those on the outside, if I'm interpreting this right. So here's a few more. So just pretty interesting how they're representing this data. I mean, I guess if I'm interpreting these things right, which I mean, yeah, there's There's a chance I'm not, but I think I am. Um, uh, it's kind of neat. It's kind of neat to see this internal motion um, of these objects. So pretty cool. Uh, how much do I want to get into this? Yeah, I think they did this for quite a few of them. I'm trying to remember what was next in terms of. Okay, so yeah, this is just more of those radial profiles, right? But now they're actually uh, measuring radial velocities as well. So you got proper motion over here, radial velocity over here versus radius. And, I'm starting to look at this and be like, well, you're trying to fit these lines to pretty sparse data and pretty, relatively speaking, pretty noisy data, right? I mean, some pretty big error bars here. So, it's starting to stretch the imagination a little bit, I think there. But, I mean, do it. Do it. So what? Right? Gotta try. And, if you think you're onto something, then it's up to you to convince the rest of us. Right? So don't give up. Keep trying. I'm not gonna I'm not gonna knock anything at all. But some of these things are getting pretty questionable, right? So this V over sigma value, they actually explain up here. Um, it's the ratio between the peak of the rotation and the central velocity dispersion. Um, so uh, I'm I'm not really quite sure how to interpret that in terms of a physical explanation. So yeah, the ratio between the peak of the rotation, so the fastest rotation, and the central velocity dispersion. Um, yeah, I'm not quite sure how to understand that in a physical way. And I look at these plots and I don't know. You know, I'm I mean, they're pretty sparse, right? But that's okay. But they're thinking that they're seeing relationships here that I don't know. I don't know. And they're plotting this value which I don't sorry, I just don't understand it. Um, versus all kinds of other things, right? Um, ellipticity of the cluster. What's log t's? The half mass relaxation time. Not sure what that is. Metallicity. Okay, that I understand. Concentration, which is just like the number of stars per area. Uh, mass to light ratios, um, and total cluster mass. So yeah, maybe I guess if I understood what this V over sigma was a little bit more, maybe I would understand these plots a little better. But just looking at the plots, face value of the plots, I don't know. I don't know, guys. I'm seeing sort of just scattered data here. So yeah, I mean, I could draw lots of lines through that that would look just as valid as these. So yeah, I don't know. Um, they're trying to plot it versus these various coefficients, and correlation things and all that. And it's like, I don't know. I don't know. But pretty interesting though. As I said, I really like these. I think these things are pretty cool, right? I mean, really not a lot of data though, right? I mean, five data points, five data points. I mean, that's just not a lot to work with, but it's still just kind of cool that we're, maybe understanding these a little bit. All right, well, cheers. Cheers to M22. Why don't we do a object of the day? Let's pick a let's pick an NGC object. Let's stop sharing for the moment. Let's pick a let's pick an NGC object. Right, there's 7,840 of them. Um, and yeah, let's just sort of see where that leads us. So I'm gonna I'm gonna I'm gonna start sharing again. Let's share my screen. Then I'm gonna go over to random.org. Let's pick an NGC object tonight. So there's 7,840 of those bad boys. Most of them are what are called non-stellar objects. These are objects that aren't stars, right? They're globular clusters or open clusters or planetary nebulae or gaseous nebulae or galaxies, right? So let's see what the randomness of the universe provides for us tonight. I'm totally into these kinds of things. So, all right. So we're going to pick an integer between 1 and 7840 and see what pops up. Drum roll, please. 3917. NGC 3917. Let's keep that. Let's just go right over here. So let's go over to Simbad. Always like to hit Simbad because it is the astronomical database, right? I mean, if you want to find out anything about any astronomical object at all, definitely go to Simbad first because you're going to get a lot of, basic information, right? So, what was it? Oh man, what was it? NGC what? 30? Did somebody catch what it was? Oh man, let me know in the chat if you caught it. I think it was like 3419, but I know there was a reason why I didn't want to move away from 3917. Thank you, Uncle Bill. Gee whiz, what a bonehead. Galaxy in a pair of galaxies. All right. Well, let's see if HST has looked at it also. Very likely that it right. Very likely that it hasn't. But we'll look anyway. 3917. Thanks, Uncle Bill. You're the best. See, I mean, Uncle Bill is the ninja, and he's supporting, you know, 50 of these at the same time, and he's still paying attention. That's great. Oh, they looked at it once back in 2001. Huh. Well, let's look and see. Oh, it's not even available. Oh man. Well, let's do one more thing. Let's see if they caught it on any instrument at all. Just not that one. Okay, so they did look at it with some spectrometers. So let's look at the spectra. There's a spectrum. All right, well, lots of wiggly lines. I think some of this is probably significant, I would think. Let's see what the other one is. Looks like it's going to be the same kind of thing. Yeah, yeah. Just longer wavelength. So yeah, isn't hydrogen alpha? I thought hydrogen alpha was like 68 something. Yeah. So yeah, not quite sure what we're looking at here. I mean, it may not be the spectrum of the galaxy at all, right? I mean, it might be the spectrum of the background sky for all we know. All right, well, let's see here. So there are the celestial coordinates: 11 hours, 50 minutes, 45 seconds, and a declination of positive 51 degrees, 49 minutes, 27.16 seconds. And yeah, this as Uncle Bill points out in the chat, this is up in Ursa Major. It's probably near the bowl. That's where a lot of galaxies are, and yeah, you know, this time of year is still definitely galaxy time. So we would be able to see this galaxy if we were to go out and look. Although it's pretty faint, right? There's a B magnitude, which is visible but sort of blue, right? That's why it's called B, of 12.5. So that's faint. I mean, you're gonna need a 10-inch telescope in order to really see that. An 8-inch. I'm trying to think if my 8-inch could get down to 12 and a half galaxy. Maybe, maybe. Um, but it's pretty bright in the infrared, right? J, H, and K are moving into the infrared. It's pretty bright there. Now U, G, and R are also visible filters. It's just a different set. And yeah, pretty faint in the extreme blue, and getting brighter as you moved in the infrared. So yeah, that's just um, uh, the inference there is that you know we're looking at a lot of red stars, right? Or a lot of gas and dust. And yeah, you know, looking at the picture over here, and we'll expand on this. But looking at the picture over here, yeah, it's a pretty gassy, dusty um, looking spiral galaxy that we're sort of not seeing exactly edge on, but sort of at an angle, right? So spiral galaxies are pretty round, but you know, if you look at them on edge, right, then they're going to look, you know, sort of elliptical like that, and that's just because you know we're seeing it at at some kind of funky angle there. So let's see what else we got here. There's a bunch of different names for it. Quite a few references. Okay, well, there's 144 between 1850 and 2018. So yeah, we'll have to look into that a little bit. Let's see what the distance measurements are to this guy. We can sort of infer that from the size, right? If you go back and look at the angular size, so that's 4.88 arc minutes by 1.366 arc minutes with a position angle of 74 degrees. So that's just this angle, right? This is probably north, right? So this is 90 degrees, right? Straight out like that. So 74, yeah, that looks about right. So yeah, it's 4.88 arc minutes across this way and like 1.366 arc minutes that away. That's all that means. So yeah, that's pretty small, right? That's pretty small. So yeah, it's probably going to be pretty far away. Yep. So look, it looks like the consensus here is maybe about 17 million parsecs. So let's see what that is. Grabbing my handy dandy calculator, hand calculator off my desk. So a megaparsec is 3.26 million light years. And then we're going to multiply that by 17 to get, yeah, it's, relatively close, 55,420,000 light years away. So yeah, that's actually sort of neighborhood. Um, Pretty good agreement on how far away we and it are moving away from each other, relatively speaking, about 1,000 kilometers per second or so. So that's moving. That's moving pretty well. All right, let's look at the picture. Love looking at the pictures. Digital Sky Survey might have a picture of this one. Ooh, it does. Let's look at the Digital Sky Survey. Oh, that's the Digital Sky Survey. I actually want to look at the one that we were looking at. Where? Well, we can do this. This is Digital Sky Survey. Is there a way to change that? I don't see any way to change it here. So yeah, let's let's zoom out and see what we've got in the vicinity. This said it was part of a pair of galaxies, but I don't know. I'm just seeing it sort of alone there. There's definitely something here, but that one looks smaller. So I'm sort of guessing that that's sort of behind this one. There's a couple others here too. All right, well that's pretty cool. Let's look at the Sloan Digital Sky Survey image. That's what we were. Oh, I guess that's what we were looking at. Okay, so we were looking at the one that I was interested in, the Sloan Digital Sky Survey. So pretty gassy and dusty, right? You can see lots of interesting details here too. So yeah, the fact that you can see those kinds of details probably means it's pretty close. Doesn't always mean that. It's a pretty one though. This one's kind of cool too, right? That's probably also a spiral, but we're seeing it almost exactly edge on, right? So we're just seeing um, a thin little thingy there. Let's zoom out a little bit. So it looks like there's an elliptical galaxy up here. That's a star, of course. So all these stars, all the stars that you see, right, are in the foreground, right? They're in our galaxy, and this galaxy and that one, and whoop, and that one and that one, and this thing over here, and I don't know. There looks like there's a concentration of something. We'll zoom in here in a second. All everything else is behind all of these stars, right? They're way out there. So let's sort of see what. Wow, there's something interesting going on there. I don't know what that is. If that's some kind of internal reflection or what. But yeah, look at that. There's a little cluster of galaxies here. Zoom out a little bit. That's quite a cluster. That's impressive. How many galaxies do you think are in that one? I mean, almost everything in here is a galaxy. Wow, that's pretty cool. That's pretty impressive. Lots and lots of galaxies. There's something called the vacuum cleaner galaxy nearby. Where? How close? Should I zoom out? See if we can find the vacuum cleaner galaxy. Is it that one? I don't know. There's something weird up here too. There's some kind of weird optical effect. I'm going to zoom out a little bit more, see if there's anything else. Oh, I don't know what that did. Oh, there we go. Yeah, Uncle Bill, not quite sure. Not quite sure where that is. You'll have to give me maybe a little more guidance. That looks like just a star of some sort. Yeah. Wherever we look, though, there's galaxies, right? I mean, there's lots of galaxies. Anyway, this is our little guy. I'll can I double click on that and then zoom back in? No, that's not the right one. Uh-oh. Now we're in big trouble. Now we're in big trouble. I'm gonna have to go back here and grab it like that again. Let's just look at the digital sky survey image. I think can we do that? See if it comes up with yeah, that looks like the same one as before. So not quite sure how to get to that other sky survey. Oh, okay. M109. Yeah, if it's near M109, then it's got to be near M97 as well, right? The Owl Nebula. But I didn't see the Owl Nebula anywhere around. This is probably M109, right? So the Owl Nebula should be up here. Should be over here. I think if that, maybe that's M109. The Owl Nebula should be, I don't know. I thought M109 and the Owl Nebula were right next to one another, or relatively close to one another. But I'm not seeing it here. I'm going to zoom out a wee bit more. Maybe I thought it was this way. Well, now I'm really, yeah. All right. Well, I'm not gonna try too hard. I'm not gonna try too hard to find the owl in here. All right. Let's go back and look at some of the papers. I'm kind of, I'm kind of curious if we have papers that go back to 1850. I'm sort of curious about what those papers are. Should we go back and look at the earliest one? Oh, all right, we'll check that later. Check it later. Let's go. Let's just go to the bottom here and see all the references. Well, this only goes back to 1975. Didn't it say 1850? Hmm. Stubborn I am. Oh, maybe I'm not quite sure, I guess. Table. Stubborn I am. Yeah, that's even worse. Well, let's see here. Whoop, sorry. Sorry for making you dizzy there. Surface brightness, color profiles, testing feedback, modified dark matter halos, and galaxy rotation curves. Okay. Spitzer photometry, Pauly-Fisher relation. That's a way of measuring distances. Active galactic nuclei. Maybe it's got an AGN in it. Hunting for supermassive black holes in nearby galaxies with the Hobby Eberly telescope. I think that's in Australia, isn't it? Maybe not. It's in Texas. Yeah, I'm not quite sure what the pair of galaxies mean. Uh, that's one of the strange things that I've noticed about Simbad is that their sort of descriptions sometimes are a little strange. Visual survey of 18,020 objects from the 2MFGC catalog. Okay, it's like some some Russians or something there. It's pretty cool. Imaging, baryonic, Mondian dark matter. It looks like they're looking at the rotation curves of this galaxy a little bit. That's pretty cool. Doesn't look like there's anything particularly exciting about this galaxy, except for the fact that it is one, and it's very far away, and it's nice looking. Rotation curve shapes of lake type dwarf galaxies. Nearby galaxies in the 2 mu m all sky survey, the 2 micrometer all sky survey. That's 2 mass. More rotation curve stuff. Star forming galaxies. Spectrophotometric survey. Bar galaxy. Yeah, I don't know if I would call that a bar galaxy or not. As I said, sometimes these references don't actually reference these objects, and I'm sort of at a loss to understand why some of the references are even here, right? Bulge disk decomposition of 659 spiral and lenticular galaxy brightness profiles. Huh. It's a little interesting. Not going to take up too much more time here. Oh, we'll take a quick look. Dun, 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 dun. Bulge disk decomposition of 659 spiral and lenticular galaxy brightness profiles. Huh. We present one of the largest homogeneous sets of spiral and lenticular galaxy brightness profile decompositions completed to date. Of the 659 galaxies in the sample, 620 were successfully fit with the chosen fitting functions. Decomposition. Now I knew the owl was around there somewhere, Uncle Bill. I'm a little I'm a little bit of a slacker now when it comes to finding objects in the sky. I need to get some practice in. All right. Well, as you know, what I go for is the pictures. Let's see if there's any interesting pictures, plots. Wow, this is a long paper. Look at this. This is a 64-page paper. Holy moly. Wow. It blows my mind that people work so hard on these things. It's incredible. Okay, so this is just like a radial plot, except it's just measuring the brightness as a function of radius. So yeah, I mean, obviously, you know, the brighter in the middle, and then it fades. And it's got an interesting shape, you know, pretty interesting shape. So what was this? This was 3917. Let's search for 3917 and see if it's in here. Doesn't look like it is. At least not that number, right? Could be called something else. Who knows? Oh, look, it's called. Yeah, no, yeah, I don't know why it wouldn't be in here, but it isn't. But look at all those brightness profiles. That's pretty cool. Some of them have some interesting structures to them. You can see that these are on the side, right? You know, they're tilted, so you're gonna have to fix yourself there to see this. But most of them look pretty bumpy. There's some smooth ones, but a lot of them are pretty bumpy. Makes sense. You know, they're spiral galaxies. They've got interesting structures. Uncle Bill, you've never seen a planetary nebula? Dude, you haven't seen like M57 yet? The ring? That's an easy one to find. It's right in between those two stars in Lyra. Right in between, like exactly in between. But yeah, um, um, most planetary nebulae are kind of hard because they look like um, a lot of them look um, uh, like planets, right? I mean, they look like small disks. Um, some of them look like stars. Some of them definitely look like stars because they're so small, right? But most of them, you know, have some kind of a physical disk, you know, that you can see. Sometimes they're small, but yeah, you definitely need to get your eyeballs on some of those photons. Um, yeah, I suppose we could blame your eyesight, but um, yeah, give it a try anyway. It's definitely worth at least seeing the Ring Nebula um, through a pretty decent sized scope, right? I mean, it looks pretty cool through a 6 inch or an 8 inch or a 10 inch, but get um, um, get yourself hooked up with like a 14 or a 16 or an 18 or a 20, and it looks really, really, really awesome. Yeah. The other planetary nebula to definitely check out because it's big is the Dumbbell M27. Yeah, check that one out. That's a big one. That's a big one. Um, easy to see that one. So, all right, well, cool. I think here's galaxy brightness profiles. Not the one that's the object of the day, though. But that's how it goes, I guess. How it goes sometimes. 3917 is just nowhere to be found. Oh well. All right. Well, I think it is time to let's see. Yeah. I am getting the call. I'm getting the call. So I better get out of here. Cheers. One more big gulp. All right. Well, take care, everybody. I will see you on the spin in a little less than 23 hours from now. We will meet up again. The circle of friends sharing a common passion. Hit the thumbs up if you prefer. Make some comments. Share this around. Look, I've got 97 subscribers. When I get to 100, right? When I get to 100 subscribers for a sustained week, right? Then this camera is going away, right? And I'm going to get a new camera, hopefully a little improved. If nothing else, I'll have a little bit more control because now I think this thing is zoomed in, so it just sees my big ugly head, which I mean I suppose isn't so bad, but yeah, I'd like it to zoom out a little bit more. I mean, I've got to sit way back. I mean this is probably close. I'm close to 4 feet away from the camera, and I'd like to zoom out even a little bit more, right? Um, but yeah, I'd like to have a little bit more control, and I think a new camera will allow me to do that. So yeah, um, Patrick, uh, as I said, I think I'm gonna uh, wait to even look until I've hit the 100, and then bang, I'll get it. So yeah, that's just a silly um, 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 arbitrary uh, goal, but yeah, have a little bit of fun. So all right, I'm gonna get out of here because yeah, they are screaming. Got to get back up. So, all right. Peace, cheers, and all of that. I will see you all tomorrow. Um, and hi to those who are watching this later. Hello from the past. It was a good past. I hope the future is about as good. So, all right. Take care, everybody. I'll see you on the spin. Bye.